Yes, so Srikal students, today we are here to learn about ions. Well, what are ions? Ion is a particle, an atom or molecule with net electrical charge. Now, that means from the definition that ions can exist in atoms as well as in molecules. That means the base for their formation can be elements or compounds. Well, the charge of electron is considered negative. We know that one electron, we say one negative charge, as opposed to one proton with one positive charge. Negative charge of an ion is equal and opposite to charged proton or protons, right? Considered positive by convention. Well, see students, let's discuss how ions are formed. Well, ions are of three different types. They can be cations, they can be anions, or they can be polyatomic ions. Let's first discuss how the ions are formed. Well, as such, atom is electrically neutral. Most of the atoms, they're electrically neutral. Let's talk about the atom of sodium. Its symbol is Na. Now, students, you see atomic number of sodium is 11. So what does that mean? In the nucleus of sodium, there are 11 protons, right? And protons means net charge of 11 protons, net charge is equal to 11 positive. To counter this, there are three shells around the sodium nuclei where 11 electrons are dispersed. So, in the first shell, according to the formula, 2n square, where n is equal to 1, so number of electrons will be 2. In the second, there will be 8. Maximum electrons in third shell can also be 8. But in this case, in the first shell, we have 2 electrons. In the second shell, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now, in the third shell, the remaining, since its atomic number is 11, so 2, 8, 1 means this will be the distribution of electrons. In the outermost shell will have 1 electron. Now, students, you know about octet. We know all the noble gases. On the right hand side of periodic table, let me just show you. See here. Well, this is our periodic table. On the right hand side, this helium, neon, argon, krypton, xenon, all these are noble gases. Why they are known as noble? Because see, when you talk about helium, its first orbit has complete 2 electrons, as opposed to hydrogen. In the first orbit, the hydrogen will have only 1 electron. So 1 electron means it always wants to be as good as noble as helium. So it will always have tendency to attract one. It will have tendency to either get 2 electrons in the orbit. Am I right? So that is the basic of hydrogen being reactive chemically. It reacts. If we talk about sodium, see here. So sodium is 11, as we have seen, 2, 8, 1. So it always wants to be something like neon previous to this. So neon is 10. 10 is in the first orbit it has 2, in the second orbit it has 8. So how can sodium become like neon? By shelling out its electron from the outermost shell. That's what I wanted to tell you. And see, in case of magnesium, its atomic number is 12, so it will shell out 2 electrons, so ultimately giving Mg ion having a net charge of Mg after giving two electrons Mg2 positive. This is how the ions are formed. Now this is how ions of metals are formed. All these are metals. So sodium, magnesium, this potassium, calcium, all these, lithium, beryllium, all these will have positive ions. Why? Because in the last orbit we have excess of electrons as opposed to nitrogen, oxygen, chlorine, bromine, etc. So these have deficiency of electrons in the outermost shell. For example, let's see chlorine, Cl. Cl is 17, so its configuration would be 287. So it wants to be something like argon. See here, argon is 18. So its outermost shell, that is octet, is complete. 2 uh, 8, 8. 2 plus 8, 10, 10 plus 8, 18. Chlorine is one shot, and that's the reason chlorine reacts with Na. So Na becomes 1 positive chlorine after accepting a negative electron, and completing its orbit, it becomes Cl negative. So this is the formation. This is the base of formation of ions. Sometimes we have positive ions, sometimes we have negative ions. Okay, so this is one classification of ions from the elements. But then we have ions from the other polyatomic ions are also there. So let's study again, right? Okay, guys. So you see here, this last electron from the outermost orbit, Na, will always have tendency to shell out this electron, so that this orbit is gone. This electron is given to some other element, which needs one electron, obviously. So in this case, it will be the best combination will be Na and Cl. So Cl electronic configuration we have seen is 287. So 7 is one deficient, one less electrons to make it equal to a noble gas argon, which is having 18, right? So after accepting one atom from the sodium, the chlorine becomes negatively charged, because as we have already stated, electron by convention we assume that it is negatively charged. And sodium, after losing the electrons, becomes positive. Why? Because initially sodium was having 11 protons and 11 electrons, and now after giving one electron it has 10 electrons, right? 10 electrons means now 10 electrons will compensate the charge of 10 proton, but one proton extra will give Na ion positive charge, and that's very right, one positive, or you can just write like this also, positive one, doesn't matter. So this is a formation of sodium ion. Similarly, students, there can be a formation of magnesium ion, because magnesium has two electrons excess in the outermost orbit. So when it will give out two electrons, as we have explained here, Mg will become plus 2. So it will be again ion, positive ion from the element, right? So these, students, positive ions. First, we talk about anions. You remember always Na. Normally, in the forms, you have this column Na that is not applicable. So you can say that N is of negative and A is of anion. So anions are negatively charged, whether they are polyatomic or whether they are from an element. So the examples of negatively charged anions we are just going to discuss. But before that, so cations we know opposite to anions they are positively charged. So we have given the example like you see we have given uh, Mg plus 2, Ca plus 2, and then sodium plus 1. So these are the examples of positively charged ions. All right, we'll come back to this and we'll discuss about one more positively charged ion from a polyatomic atom. All right, stay tuned. Well, these are anions. Most of the non-metals, students, they form anions. Why? Because most of the non-metals, as I've just shown you on the periodic table, you should also see and explore more deeply. If you talk about chlorine, 17, if you talk about oxygen, a very high tendency to accept electrons, very high. So other also, which are deficient of electrons, they will gain the electron and become negatively charged. So chlorine would be like like 2 here electrons, and then on this shell there'll be 8 electrons, and in the last shell 8 plus 2 there'll be 7 electrons. So 7 electrons means in order to complete its octet, you see the there is a kind of understanding. The scientists, the chemists, for a long time they have understood that when the octet has 8 electrons, when the octet is completed, it shows, it points towards more stability, uh, unreactive, saintly like nature, nothing to give, nothing to get. So that is what is the characteristic of noble gases. So all the elements, all the atoms, they have tendency to either give out electrons, becoming positively charged ions, or to take electrons and becoming negatively charged ions known as anions. And after giving out electrons, like most of the metals do, they become cations. Okay, guys. So Cl, so it will be Cl negative. So it will be basically when we say NaCl, we intuitively understand that this is Na1 positive and Cl1 negative. Am I right, students? Similarly, is the case of HCl, hydrochloric acid. So now, well, here the way electrons are transferred is different, but in HCl, it's different. All right, that you will learn when you learn about bonding. Here, bonding between Na and Cl is different, very strong bonding. So its melting point is very high. But HCl gas, it's acid. So its bonding is different. Here, some sort of sharing of electrons is there. So you see that H positive, H after sharing electron with Cl becomes H positive and Cl negative. Okay, so these are like, when they're in solution, HCl, uh, when they're in solution, that's the reason, in the batteries we add water. So when we add water, HCl gets split into H positive and Cl negative ions. H positive is cation, and Cl negative is, anion. But it's not the case, uh, with other. So this is all about anions and cations. And then similarly, students, in a battery, as I have discussed, there are two electrodes. So one of the electrode is positively charged, and the other electrode is negatively charged. So students, very simple. We have anions and we have cations. So you see cations, anions are negatively charged, cations are positively charged. So, opposite poles of magnet attract nature. Here also, as per that nature, the negative anions, they always go to positively charged electrode, and that is known as anode. And the cations, positively charged particles, they will always get attracted towards negatively charged electrode, known as cathode. So in nutshell, we again revise. Anions are negatively charged particles, cations are positively charged particles. Cations get attracted towards cathode, they're negatively charged electrodes, And from this comes to my mind is CRT tubes. We used to use previously in TVs and all, cathode ray tube, discharge of electrons. Okay, so this is all about anions and cations, students. And then after this, we have what is important is polyatomic ions. So as in the definition, students, we had seen that atoms or group of atoms, right? That is molecules. When they lose or gain electrons, they become charged. So we have discussed about anions and cations. In that case, atoms are losing or gaining the electrons. So they become, when they lose electrons, they become positively charged, you know, cations, and when they gain the electrons, they become negatively charged anions. But then, but then the same inherent properties exhibited by group of atoms, that is molecules also. So let's see how's that. So even molecules have, mm, net electrical charge. So first example is nitrate ion, carbonate ion, sulfate ion. So interestingly, students, nitrate ion is NO3 negative. All right. Carbonate ion is CO3 2 negative. That is, they have gained two electrons. Sulfate ion, SO4 2 negative. Sulfate ion you can see in sulfuric acid. Sulfate ion, sulfuric acid. Carbonate ion you will see in carbonic acid. H2CO3 is carbonic acid. Nitrate ion is NO3 negative, that is HNO3 nitric acid. Now you remember, acid fall, acid rain, nitric acid, formation of nitric acid. Okay, very important thing. Now, the question is, we have discussed all the three negative ions from the compounds. Are all the polyatomic ions negative? So the answer is, if you see all these ions, as most of the polyatomic ions are negative, they have oxygen in them. And oxygen, as just told before, it has great tendency to select the electrons. Okay, so they attract the electrons, and that's why these are negatively charged. So, but ammonium is one of the few positively charged polyatomic ions. It's a cation and doesn't contain oxygen. Yes, students, not all the polyatomic ions are negative. We have some polyatomic ions, but very few. Ammonium is one example. Very few positively charged ions we have. So this is a cation, and obviously it doesn't contain oxygen. So Nh4 positive. Let's see how is the formation of Nh4 positive. You see, N, we have already discussed, nitrogen is 7 atomic number, right? 7 atomic number means its configuration would be 2 and 5. In the first shell, 2 electrons. In the second shell, 5 electrons. 5 electrons means it's short of 3 electrons to complete the octet. So N is short of 3, H is short of 1, H atomic number is 1. So you see that, students, when they combine and H, you know, when they combine, so it's like NH. They are as a molecule of nitrogen and hydrogen. They are short of 4 electrons. So obviously they'll be attracting 4 electrons. So we call it 4 positive. So students, this is all about cations, anions, and polyatomic anions. Stay tuned, subscribe the channel, and see the more videos. Thank you very much.